Okay, let's dive right in. We're looking at a really serious strategic hazard assessment today. It covers the end of November into early December 2025.
It does. And this isn't your typical winter storm forecast. The sources are flagging a high-confidence collision zone across a huge part of Europe and Russia.
A collision zone. And the core warning here is about a fundamental structural integrity threat, not just a snow day.
Exactly. We're talking about a shift from what starts as mild, wet weather into a sustained, really high-impact event. And that zone where cold and moisture meet is the focus.
So let's break that down. How are we getting such a deep, sustained blast of cold? That's the first piece of the puzzle, right?
It is. And what's happening on a large scale is a major slowdown of the polar vortex. It might even collapse.
So the wall that normally holds all that Arctic air in place,
It just
breaks down.
pretty much, it lets that frigid air just spill much further south than it should. This is what's behind the negative phases of the Arctic and North Atlantic oscillations that are setting this all up.
Okay, and I want to stop you there because this is the part that feels so counterintuitive. This is where the climate link comes in.
It is.
A warmer world should mean milder winters, but your sources are saying anomalously warm oceans are making this specific cold event worse. How does that work?
It's what some are calling the paradox of wet or cold. You have these record-breaking sea surface temperatures in the North Atlantic and the Med.
Right.
All that warm water acts like a giant engine for evaporation. It's just pumping a massive surplus of moisture into the atmosphere.
So you have this deep, established Arctic air, and it's about to slam into air that's loaded with almost tropical levels of moisture.
Precisely. And that collision is what makes this so dangerous. You don't get light, fluffy powder. You get this incredibly heavy, wet snow, or even worse, freezing rain.
And that weight is the structural integrity threat you mentioned, the loading stress?
That's the one. It's what brings down power lines, what collapses roofs, a completely different kind of threat.
So let's talk impacts on the ground. The sources are pointing to Central and Eastern Europe as a major hotspot.
Yes, and specifically for freezing rain and ice storms. That's the highest risk there.
And the benchmark they're worried about is a 1/4 inch of ice accretion.
That's right. Doesn't sound like much, I know, but a 1/4 inch, or about 6 millimeters, of ice is the threshold for an ice storm warning. It's more than enough to snap tree limbs and trigger widespread grid failure.
A catastrophic threat to the power grid, then. Now, what happens when we shift east into western and central Russia, where the cold is already locked in?
There, the threat changes. All that moisture translates directly into just extreme amounts of snow. You're looking at blizzard conditions.
And what does that mean in terms of criteria?
It means you're seeing 25 centimeters or more of snow a day.
Yeah.
But critically, it's combined with high winds, over 35 miles per hour. Visibility just drops to near zero.
So logistical paralysis.
Power paralysis. It effectively shuts down transportation networks.
And finally, the Caucasus. The sources call the geography there a threat multiplier.
Right, because the mountains force all that moisture-rich air upward very, very quickly. It's a process called orographic lift.
And that squeezes all the moisture out.
Like a sponge. It causes explosive cooling and a massive release of snow. We're talking crippling high-altitude blizzards, huge avalanche risk, and communities being completely isolated for days.
So pulling it all together, it's a dual-factor threat. You have the dynamics of the polar vortex forcing the cold south.
And you have the thermodynamics of warm oceans supercharging the moisture available to that cold air.
Which brings us to the final, I think, really provocative thought from the source material. It's about how to manage this risk.
Yes. The assessment is very clear. Given the catastrophic consequences of that 1/4 inch of ice, you can't wait for certainty. Can't wait for a perfect forecast.
You have to prepare for the worst-case scenario.
You have to. The source recommends adopting that posture across the entire mixed precipitation zone. And it leaves you with a question, really. When the cost of being wrong is this high, how can any government or utility afford not to prepare for the worst?